All right, today we are learning about solving inequalities with multiplication and division, and this is kind of an extension from kind of what we learned in those first couple lessons in the last unit. All right, so day 4 starts today. All right, so in example 1, it says we're going to multiply or divide by positive numbers. So what are they talking about with positive numbers? Well, you'll see the difference between example 1 and example 2. In example 1, we have positive numbers connected to our variable, either by division or multiplication. Okay, so we see 8 is positive, we see 3 is positive. So when it says positive numbers, it doesn't mean every number in the inequality is positive. It just means the number connected to the variable, and that's really important. All right, we see the same thing with the third problem. There's a positive number connected to the variable. All right, so the similarity that you'll see here is that we solve inequalities the same way that we solve equations. All right, so how could I get x by itself? Well, because this is division, I would multiply by the reciprocal. So 8 over 1 now cross reduces your 8s, and you're just left with x. But whatever you do to one side, you have to do to the other side. So 5 times 8, which is 40. All right, and you guys have done enough problems up until this point. You know, we don't end there. We need to graph it. Now, this is something on your homework assignments, they kind of give you that number line, so you don't have to necessarily make up the numbers on your homework assignment. They're already in there, but you do have to decide from a list of choices. All right, so if you remember, there's like a list of choices underneath, and one of them might look like an open dot, arrow to the right, open dot, arrow to the left, closed dot, arrow to the right, or closed dot, arrow to the left. All right, and those are your options. So then you would click whatever option you think would represent this inequality. So x, or all numbers greater than 40, would be a solution. So this is greater than, it's not equal to because there's no equal to bar underneath. So greater than, my arrow would go to the right. So on your homework assignments, you would select that inequality, and then you would go up and click it on the number that you would want to start it, and then you would extend your arrow. All right, so that's kind of how it's going to look. I'm not going to do all those options for all the problems, but that's how it's going to look on your homework assignment. All right, so next problem. Now, what operation is connected to your variable? All right, you should be thinking multiplication, right? So how do I get x by itself? I need to divide by 3 because I have to do the opposite. So now, here's my answer. Now, the problem with this is that my variable is second, and we talked about this. So you actually could have rewritten the original problem as long as you rewrite it before you graph it. Okay, because right now this looks like a greater than symbol, but it's actually not. The x, the inequality, is closed off towards the x. So when I rewrite it, I can now see that actually all solutions must be less than or equal to -8. Now I'm ready to graph. -8 to the left is -9, -7. Now, would this be an open dot or a closed dot? All right, hopefully you're thinking closed dot. And less than means that all my other solutions, remember guys, with inequalities, there are an infinite number of solutions to an equation. So that was on your last test. It was something along the lines of, with inequalities, there is one and only one solution. That's not right, because what we're showing here is that there's actually an infinite number of solutions to an inequality. All right, so third problem is just kind of more of the same. Obviously, we see a decimal, but that's not a big deal. We're allowed to use our basic 4-function calculators. So I want you to go ahead and solve this one. Go ahead and solve it ahead of me. I want you to come up with your answer. And remember, this Q is coming second, so you're going to have to rewrite it. Okay, so 18 divided by 1.5, negative 18. Okay, divide both sides by 1.5, and I get 12. Okay, but remember, before I graph it, I need to make sure that I write this inequality, rewrite it with my variable first. Q is less than 12. All right, so hopefully you got that answer before I worked this problem. All right, so now I'm ready to graph 12, 11, 13. Open or close dot. Open, and my arrow going left. Okay, for less than. All right, so solving with multiplication and division. Now, the only difference that we see here on example 2 is now it says I'm multiplying or dividing by negative numbers. And what that means is there's now a negative number connected to my variable. There's a negative number here connected to my variable. There's a negative number here connected to my variable. And when I see that, again, this negative number over here makes no difference. But if there's a negative number here connected to my variable, that's a problem. Okay, not a problem, but that's going to cause something to happen. All right, so I still follow the same process. How do I get rid of the division? I need to multiply. But because there was a negative number connected to my variable, when I multiply, now instead of my sign being greater than, now my sign is less than -6. So that's going to completely change the graph of my answer. So now I have -6, -7, and -5. If you miss this, you're going to end up drawing a greater than symbol and you only get half credit. Okay, so open dot, and because we caught that we had to flip our inequality, our arrow is going left now. All right, so you see, guys, we solved the problem, we solved the inequality the same way. We just recognize multiplication and division only. It does not matter with addition and subtraction, but if there's a negative number connected to the variable, then I must reverse the inequality. So how would I solve for y here? All right, go ahead and try to do that ahead of me. Okay, hopefully you divided by -7, right? To solve for y, divide by -7. But because that negative was connected to my variable, now it's y is greater than or equal to, and would this be +5 or -5? Hopefully you're thinking negative or +5. +5. All right, so now we do our number line. 5 is in the middle. It's our solution. Okay, and is it an open dot or a closed dot? All right, so you would choose the closed dot option, and your arrow is now going to the right. Okay, showing that all solutions can be greater than or equal to 5. That means if I were to plug in 6 up here, then that would actually make the inequality true. All right, last one. I want you to do this one on your own. Go ahead and do this on your own real quick. Okay, so we see that negative is again connected to our variable. Okay, so now instead of it being greater than, now it's less than or equal to. And when I do this division, it becomes -30. So come down here and I just graph my solution. -30, -31, and -29. And would it be an open dot or a closed dot? All right, it's closed. And my arrow is going to the left. All right. So we've looked at in examples 1 and 2. In example 1, I was just solving, but I had a positive number connected to my variable. In example 2, I'm solving, but I have a negative number connected to my variable. Now, in example 3, you have 2 problems on your homework, and this could definitely show up on a quiz or a test as well, where you have to write your own inequality and solve it. So when you have to do that, and you guys have seen this in the last unit, it's important that you try to find those hints in the problem that that would help you figure out what inequality symbol to put in there. All right, so you have $15 to buy 6 plants for your flower bed. You need to write and solve an inequality that represents the prices that you can pay per plant. So remember what I told you about writing an inequality. We always want our total to be on one side of the inequality, and in this case you want it to be after the inequality because you want your variable to come first. So the total amount of money that you have is $15, right? And you know that you have to buy how many plants? 6 plants, but you don't know what those prices can be. Now here's the question. Does the cost of the plant, okay, you always ask yourself, this combination, does it need to be less than, greater than, or equal to, okay, those different parts, 15. So if you have $15, you can't go over that. All right, you'll be embarrassed at the cash register when you don't have enough money. So less than, but if you have right at $15, you'll be fine. So that's why it can be equal to also. So there is my inequality. But now it says I need to solve it. So that's not bad. Just divide both sides by 6. And P is less than or equal to 2.5. And in this case, it would be $2.50. All right, so don't forget if it's money, you need to make sure you write your answer as money. So that's how much I can pay per plant. That's really helpful. All right, if you're trying to do your landscaping and you're figuring out, you know, what you can buy, now you're only looking for the plants. If you know you need 6, they're $2.50 or less. Okay, so that actually can be really important, you know, in real life. All right, so the next one, this is the last problem we'll work. It says a weather forecaster predicts that the temperature will decrease 2 degrees Fahrenheit each hour for the next 8 hours. Write and solve an inequality to determine how many hours it will take for the temperature to drop at least 22 degrees Fahrenheit. Okay, so in this case, they kind of threw in some information in here that's a little bit of a diversion, okay? Over the next 8 hours, that really isn't going to play too much into how we're going to write this inequality. The decrease in the temperature is going to be important. And again, I'm looking for some kind of a total or a final amount. I want to know how long it's going to take for the temperature to drop 22 degrees Fahrenheit. So that's how many degrees it's going to drop. All right, so 22 is my total. Okay, but if it's dropping 22, would 22 be positive or negative? It would be negative. And if temperatures are decreasing by 2 degrees Fahrenheit, would that be positive or negative? All right, so this is where you really have to pay attention, and the problem will give you clues if these values are supposed to be negative. All right, again, I don't know how many hours it's going to take, so that's why the T is connected to the -2. If it drops for 5 hours, then I know how many degrees it drops, okay? Because I would multiply it. So now it says, how long will it take for the temperature to drop at least? So the minimum it's going to be is this amount. So that means that this temperature drop needs to be greater than or equal to negative 22. All right, so here's where it gets interesting, because look what's connected to my variable. Okay, and you have a problem just like this on your homework, just different numbers. I need to divide by negative 2, both sides. And what happens is now my answer switches. Less than or equal to 11, and remember what T stood for, hours. So what we're saying is, if it's dropping 2 degrees per hour, and it needs to drop at least 22 degrees, it's going to take 11 hours, right? That makes sense. It's going to take at least 11 hours. So after 12 hours, it's dropped 24 degrees, which is at least 22. Okay, so I've answered this question. All right, so these are really similar to the problems that you'll have on your homework assignment. And if you understand that, that's everything you need to know for day 4.